All right, so we're talking about arrays and vectors today. Not too bad, hopefully. You really do need to understand how a loop works in order to be able to use an array, because in order to use an array, you have to be able to use a loop to get through it. So an array is just another type of variable that we have. Okay, so we have variables, but if we wanted to have, let's say, 50 temperatures that we wanted to store, we wouldn't want to create 50 temperature variables to store that. It would be easier if we would be able to have an array, which is basically like a list to store all those values. Okay, so we would be able to give that variable one name, we can call it temperature, and then we would be able to put the values in there, and it would actually store the values in an array, and then we would be able to access them based on an index location. So that's what we're going to talk about today. So if you understand the different data types for variables and you understand how a for loop works, then hopefully this won't be that bad. But if for loops are still a little tricky, we have to use for loops to get through our arrays. And so we really need to fix that. We need to make that make sense because then the code to access the array won't make sense. So if you still feel like you need some help, please don't, hesitate to get some help. Matt is available as well. So if I've explained it to you and it still doesn't make sense, please remember that Matt is available to help us with tutoring. So if you want to reach out to him, he has his email addresses on there, and he's at the Spring Creek campus, unfortunately, but he can help as well. So something to think about. Okay, so we're going to start chapter 7 today, arrays and vectors. So I'd like to walk you through this. I know there's a lot of slides, but bear with me, it's not too bad once we get started. So arrays can hold multiple values. So basically, we're talking about a variable that can hold multiple values. And so again, if we're thinking about temperatures and we wanted to store 50 temperatures, again, we wouldn't want to have a temperature 1 variable, temperature 2 variable, temperature 3 variable, temperature 4, because there's no way to easily access those variables. You can't have a loop go through those because they're just individual variable names. And so you'd have to access them all individually. You'd have to put them into all 50 values into there. All 50 values get pulled out. What if you had 1,000? That's just very inefficient and not flexible. So how can we do that? We can do that with an array. And so with an array, we have to have a variable type that's the same, but we can store multiple values in there. So like if we can have an array of integers or an array of strings or an array of characters, array of booleans, okay? But they're going to be the same data type, okay? So temperatures, we might make those integers, or maybe we think we need the decimal, we might make them doubles, okay? So they're going to be stored in adjacent memory locations, and we're going to access them with something known as a subscript. Some people call it an element or index, okay? So in this case, you can see here, we have a variable that's called tests, okay? And it's an integer data type, so it's going to be whole numbers. And this right here, these little square brackets means array, okay? So the 5 in there indicates the size of the array. How big is the array going to be? Well, 5 indicates that you can have 5 values, okay? And they must be integer values since it's an integer array, okay? So this is how you actually can declare an array, and you give it the data type, the name, and the size, okay? So 5 values in there. Does that make sense to everybody so far? Okay. So it looks like this. We have these elements that we put in there, and then we are going to have, we call them a subscript or an index location where we actually pull the values, pull the element out, okay? So we talk about int is the data type, test is the name, 5 is the size declarator, and that's how many elements you're going to have in your array, okay? So the size tells you how many bytes that it needs to set aside for it, because a 50 value array, 50 elements is going to be, much more than 5. So we need enough space for that. So we need to know the size of it so we know how much storage space to set aside for it. Okay, so example here, if we had 5 tests, that would take up 20 bytes. If it was an integer array, and if you had one that was 10, that was a long double, that would take up 80. And so it takes up space depending on what data type it is and how many elements you're going to have. So that's how we know how much space to set aside. Okay. So the size declarators are to tell it how much space is needed, basically. So you can create a constant variable that represents the size declarator, or you can just put the value in here. The reason for doing this is because if you want to change this number 5 and make it 10 in the future or 20, you can actually, if you make it a variable, it's a little easier to work with because you can get input from the user and ask them how many tests they want to have, and then that value can change in the variable. Whereas if you just put 5 in here, that wouldn't change. That would always be 5, and so you have to go actually put a new number in there, and that's something that you can't get input from the user for. So if you make it a variable, you could do like a cout and a cin statement asking the user for how big they want it to be, how large they want, and then you can use that variable to actually create your array, okay, based on how large they want it to be. So it's easier, it's more flexible to use a variable, a constant for the declarator instead of just putting a number into here, but you can just put a number in here. It's just the value that's being used, so it works the same. Everybody good so far? So far so good? Okay, so subscripts or index values actually start at 0. And this sounds really strange. And I talked about this a little bit with loops. That's why sometimes people start their for loops at 0 instead of starting at 1. Because anytime you're working with, strings, or you're working with arrays, when you're talking about the string index locations of the actual characters in the string, if you were to access the characters of the string, you would start talking at 0 as the index location. If you're talking about an array, it starts counting at 0. I know that sounds very strange because we start counting at 1, but the index location, the subscript for arrays starts at 0. So keep that in mind, because whenever you're talking about a size of 5, you actually would only go to index 4, okay, because you're starting at 0. All right, so this one actually has 6, because if you were to count them 1, 2, 3, 4, 5, 6, this is a size of 6, right? So it changes the way you write your loop, because if you have a size of 6, for example, then you want to go until less than 5 when you're doing it, and you need to start at 0, okay? So just remember you're starting at 0, you need to add an extra one on there when you're talking about when to stop it, okay? So the last element's always n-1 for the size, based on the size. So if you had, 6, then the last actual index location would be 5 because you're starting at 0, okay? If you started at 1, it would be 6, right? But if you started 0, it's actually 5. So they say it's n-1 because you got to count for 0. Does that make sense to everybody? Okay. All right. So how do you access it? So let's say we wanted to put a value into test, the first value into the test array. Okay. Well, the first value would actually be an index location 0. Okay, because that's where the first value goes, because that's where it starts counting. And so you can't just say test equals and put the value in there, because it needs to know which index location to put it into, because you have multiple index locations. So it needs to know which one do I put it into, which slot do I put it into. So you're going to say 0 for the first one, and then you can put, for example, 79 in there. So, 79 would go into the first index location of the test array. That makes sense, everybody? Okay, and then what if you want to print out that first value? Well, you just say test index location 0. Remember to use the square bracket, okay? And then this one pulls the first value. What if you wanted to take in something and put it in the second value? Well, test index location 1 would actually put it into the second value of the array, the second location, okay? All right, this just shows that you can add different values together. So if you're talking about that integer array of tests, you can add the first value and the second value and then put it in the fourth index location. Okay, it's just trying to show you that when you write something like that, this test index 0, it's just going to pull a value, whatever value is in that location. And then this one's just going to pull a value. And then it's going to add those two values together. And then where's it going to put it? It's going to put it in this location of the array. And so you can do arithmetic with values from the array, but just saying the name of the array and then the index location. So it's just like a variable, except you have to specify the index location because it has to know which value you want. All right, you cannot just put test here like this because it doesn't know which value. It doesn't know which location, and it won't print all the values. Unfortunately, you can't just put tests and it prints the whole array. You have to actually go through every element of the array for it to work. Okay, that's where the loop comes in, right? But you can't do that, unfortunately. That makes sense, everybody? It'd be nice if you could, but you can't do that. So if you don't put the index location of what you're trying to pull, when you're putting something in or trying to pull something out, then it's not going to work. Okay, so you have to actually say what value. Okay, so here's an example of entering the numbers worked. So here you have a C out that says enter the numbers worked. Okay, and then you're going to put a value into the first index location, the second one, the third, the fourth, the fifth, and the sixth. So you have 6 locations, and you're going to put values in, and then you're going to enter them, display them back out with the C out. So you're probably saying to yourself, what if I had like 100? This would be very inefficient, right? That's where a loop comes in. We're going to talk about a loop in just a bit, but this is the longhand way to do it. But we don't want to do that. We actually would like to use a loop for this because you can see that the array is the same. The numbers are just changing here. So that's something easy that you can loop through. Okay, because it's easy to change that. So you can see if you enter these numbers here, 20, 12, 40, 30, 30, and 15, then it would just display them back out because you're just printing those values back out. So there's 6 values and it just displays those 6 values. And then here's what it looks like. Index location 0 is 20 because that's the first number you entered. I know that's tricky because the first number going into index location 0 is kind of hard to get used to, but try to remember that. And then 12 goes into index location 1, which is actually the second value. And then 40 goes into index location 2, 30 goes into index location 3, the other 30 goes into index location 4, and then 15. So again, there's 6 values, but you only go to index location 5, and that's because you start counting at 0. Everybody with me on how that works? If you're confused, let me know because I don't want it to get more confusing. Okay. All right, so you can access by saying the index location. All right, and this is the reason why I'm mentioning this is because we are going to use a loop to do this because I just showed you the longhand way to take in input through the C in and the C out for every single index location value, but you can easily loop through them. And so just like you can put here test location index 3, you can create a variable here that says 5, I is 5, and then just use the variable here. And if you can use a variable here for the index number, it can actually change. So we can change the index number instead of putting each one like this, like we had before the longhand way. So if we can do that, we can write a loop to actually access the values or to put values into the array. And so a loop works for putting them in and for taking them out. So this one, you can see the array size is 5. So it's a constant, and you can change that number if you didn't like 5 and you wanted 10 or you wanted 20. But we're going to use that throughout our program for the array size. And then here, when you create the array, you're going to use that array size variable. So if you put 5 there, this would be 5. So you would have 5 values, 5 elements in your array. Okay. Now, when you're writing a for loop for your array, you want to start at 0 because your array index values start at 0. Okay, so I know that sounds tricky, but you want to start your loop at 0. So this actually could be I, it could be count, whatever you think makes sense. It could be A or X or, it's just a variable name. So here we're going to start at 0 and you're going to make it an integer because when you're doing a for loop, you're always going to count. You're not going to count by decimal numbers. Okay, and each index value is going to be an integer one. So we're going to start counting at 0. And then we're going to go until count is less than the array size, which in this case is 5, but that could change. That could be 10 or 20 or 50. It's easy to change that. That's how flexible it is. Okay, so here we're going to go till 5. You might say, why does it count as less than 5? What do you want less than equal to 5? Well, when you're doing it, remember that you start at 0. So you're going to go 0, 1, 2, 3, 4, 5. But you don't want to include 5 because if you have 5 values, index location 5 actually isn't going to get a value because you started at 0. So you're actually going to use 0, 1, 2, 3, 4. And if you count 0, 1, 2, 3, 4, that's actually 5 values. Okay, so remember, when you do your loop, you always go to less than the array size. You don't include the array size. You don't put equal to here and include the array size because that'll go 1 too far because you started at 0. And we'll talk about what happens when you go one too far in just a bit. Okay. Now, you want to count by ones because you want to include every index value. So you want to get the first index value, the second one, the third, the fourth, the fifth, right? But we don't have a fifth one in this one, right? Just 0, 1, 2, 3, 4. Okay. So what's going to happen here is it's going to start at 0, count to 0, and 0 is less than 5. So we're going to do it the first time. So when we do this, it's going to say, okay, take 99 and put that in numbers with the value of count, the index of count. So count is 0, right? So numbers index 0, and this is the numbers array. The first value of the numbers array is going to be 99. It's going to put 99 in there. Then it's going to increment count. So count will become 1, right? And it's going to do it again because this actually is true. It's going to put 99 in the second location, which is index location 1. So index location 0 gets 99. Index location 1 gets 99. Okay. Hold on just a second, guys. Let me bring up my notepad just so you can see. Okay, so what we're doing here is we're actually saying numbers, index location 0, and we're putting 99 in there. Everybody with me? And then we're saying numbers. And this is very important that you get this because we're going to keep using loops to put numbers in and to take numbers out. And so I want you to understand how this variable here, this count variable in this case, is moving. It's becoming 0, then 1, then 2, and that's actually helping get through the array. Okay, so when you increment count, which is what you do as part of the loop, then you're going to go to numbers index 2, right? Okay. And you're going to put 99 in there, and you might say, why 99? This is just an example. There's no reason. Okay, could be any number you want, just putting 99 in all of the different index locations for this array. So then you're going to increment count, and count is going to become 3. Okay, so it was 0, then 1, then 2, then 3. And when it's 3, it's still going to match here. So we're doing this, we're having this count variable here, right? 0, and then it's 1, and then it's 2, and now it's 3. And each time we're testing to make sure it's less than 5. So 3 is less than 5, right? So we're going to do it again. So we're going to go numbers, index 3, and we're going to put 99 in there. Okay. Then we're going to increment count. So count is going to become 4. So we're going to do that here. 4 is less than 5, right? Okay. So we're going to do it again. So we're going to say numbers, index 4, right? We're going to put 99 in there. Okay. Then we're going to increment count. Count becomes 5. Is 5 less than 5? No. So stop. Okay. So we don't go to here, which is great because we said we had an array with 5 values. So we actually do have 5 values here. 1, 2, 3, 4, 5. It just so happens that we start at 0 and end at 4. So we have to get used to this different way of doing it. But we do have 5 values. They all happen to be 99 in this case. But this is just an example of how to get values into an array. Does that make sense, everybody? With a loop. Because the other way that we did it was inefficient. When we had put the code like this, we put the values in like this, we could use a loop for that. That would have been much easier. It doesn't really matter when you only have 5 values, but you have to imagine that that would be inefficient if you had 100, right? Somebody would make a mistake and enter the wrong number. You might put like 2 index locations that are the same and then they end up in the same one. Plus, that's just an inefficient way to access it and to put values in and to take values out. Okay, so we started counting at 0 because an array starts counting at 0, the index location for an array. Then we always want to go to less than the array size so that we can get the full array. And then you want to count by 1 so that you get each individual array index. So you put an element into index location 0, and then an element into index location 1, and an element into index location 2. Is everybody with me? Okay, perfect. All right, so if we have a global array, okay, you know the difference between global and local, where we declare it, right? We declare something in a loop, it's local for that loop. If we declare it in a function, it's going to be good for that function. If we declare it at the top of our program, it's good for the whole file. Okay, so it depends on where you declare it. So arrays that are declared as global will be initialized with 0 as default. And then local arrays, if you declare it like inside a loop, for example, it's local to the loop, won't be initialized by default. So you have to do it. Okay. When you're initializing, you can just give it a size and then put values in later. Like you might have a loop that has the person enter the values for the array. Or if you know the values, you can actually just put them in. And this is actually a curly brace here and a curly brace here. Okay, and then you just list them with commas. So if it's an integer array, you just list them with commas. If it's strings, you have to put double quotes around it. Whatever data type you're working with may look a little different, but you separate the values with commas and you do a curly brace at the beginning and curly brace at the end. And then you can also say the size. Here you have 5, and then here's the 5 values. Okay, you don't want to put more values in here than what the size is, of course, right? And if you don't put enough, then the rest will end up 0. If it's a partially filled array, it'll just put the rest to 0. If you only put 4 values, the 5th one will just be 0. Okay, so here's an example of the months. So you have 12 months, right? And then here you have an integer array for, we're going to say how many days are in a month, right? So we have an array, and we are going to have a days array, and we're going to do each of the months here. So we have, how many days each month has, right? So we went through and started with the first one and then went through all the different months. Okay, so here's our loop. This looks very similar to what we just talked about. You start your loop with 0. You're going to go the less than how many you have. Always go less than the size of the array. So if you have 12 months, then you're going to go less than 12. And so here that's a variable. And then you're going to count by 1s because you want to get every single index location of that array. Okay, so here you notice that it's +1, it's count +1, because we don't say month 0. Like for January, we don't say month 0 because that would just be strange, right? We say month 1. So just for looks for output, you don't want to say month 0 for the first one, because if you just say month and you put the count, it would say 0. So if you put count +1, and then it's going to print 1 instead of, I don't want to actually change the count though. I just want to display it differently down here. So that's why I just put count +1. It doesn't actually change the count. It doesn't modify the count. It just displays it differently. Okay. And then I'm going to display the array days with whatever count we're actually on, which is 0. I'm just making it for looks up here, say 1, but it's actually January is 0 because that's the first index of the array. So it says month 1 has 31, month 2 has 28. So this is February 1st, January, February, March. Okay. So you can see how when you're doing it for people to look at, when you're doing like output or you're doing input, you don't want to start counting 0 because that confuses people. We don't ever start counting in real everyday life, right? But as a programmer, you have to know that the actual index location starts at 0. But to make it look good for people that are using your system, you don't want to start counting at 0. So you just add 1 to the counter so that it looks like it starts at 1, even though it's starting at 0. So you're not actually modifying it. It really is still just working with starting with 0, but to display to everyone else, it shows them starting with 1 instead of 0. Does that make sense why we do that? That would be really confusing if you said month 0 has 31, right? So we're just kind of making it look nice here. Does everybody understand this code? Not too bad. Are y'all okay on Zoom? So far, so good?
Yes.
Okay, perfect.
Yeah.
All right, good. So we talked about this a little bit. If you had part of the numbers done in the array, a partially filled array, I'll just put the rest with 0. Okay, you don't have to necessarily put the size here because it can determine the size based on how many values you have. So if you are putting the values in here and you're initializing the list instead of having it come in from the user, then you don't have to put the number in there, but you can. Okay, it's not required. But if you don't put the values in here like this, then you do have to put the size because you have to know how much storage space we need. If it has the values, then it knows how much storage space because it actually has the values. But if it doesn't have the values, it needs to know the size because it needs to take what data type are you working with and what the size is to determine how much storage space is needed. Okay. So you can't just leave it wide open because there's a big difference between 1,000 values and 5, right? How much storage we need. Okay, there's no bounds checking in C++. So I know in Java, for example, if you go too far in an array, it says array index out of bounds, okay? But in C++, if you go too far, it actually puts those values in there, but you can cause problems later, okay? So you need to kind of do that on your own and pay attention to that. So here's an example of that. You have a size of 3, okay? So this array has a size of 3. So it really should have index value 0, 1, 2, and no more than that, right? Because it has a size of 3. So when you try to put 5 numbers into an array that's only a size of 3, then it causes problems. So you can see you start at 0, which is perfect. Here, you go to less than 5. That's not right, though. It should be less than 3, right? Not less than 5. And then each time by 1. So here it's going to take 100 and put it in there, but it doesn't have those 2 extra locations to put it into because you didn't create that. So here's what happens. It puts the first 3 in, and then you have these extra overwritten values that aren't supposed to be there because these index values don't exist. And so this is going to cause all kinds of problems later because there might be things written there. It's not expecting those values. Those values aren't supposed to be there. It didn't set aside storage for those values. And so they might get put there, but they might cause problems. Okay, so you have to be aware of that. Don't make your loop go too far so that you're trying to put values or access values that don't exist. Okay, so that this is what this is talking about. Invalid subscripts would be those, basically you're going to 5, but you only have 3. So if you have a size of 3, you only go to 3. Okay, that's why it's nice when you do your loop, instead of using a number here, use the variable so that if this changes, that changes too. So the variable updates everything, because if you do put numbers, sometimes that you can forget to change things. Like let's say this used to be 5, but I forgot to update the loop. I changed this, but I didn't change this. You know, I use the variable here, right? And then I don't have that problem. If I just use that size variable, then I don't have a problem with it updating and actually having to manually go back there and change the size. So it's more flexible and it creates less errors. Okay. Does that make sense, everybody? The other issue, there's possible that you could forget to start at 0, right? And you start at 1 because a lot of times when we're counting, we start at 1. So when you're first getting used to it, maybe you start your count at 1 instead of 0. Then what happens is it's going to skip that indexation 0. And so then if someone tries to access indexation 0, then there's not going to be your value in there. It's actually starting at 1. So just be careful, you know, when you're doing it, that you start at 0. Account for that. Make sure everybody else is starting at 0. Okay. There's actually a special loop that's used for an array. So instead of having to do the for loop where we do, you know, the count equals 0, we go to less than the size, and then we count by 1s. We can actually have a special loop for that, range-based loop. And so what you do is you actually put the data type here. So and then the range variable, and then what's your array name, and then whatever you want to do inside here for your for loop. Okay. So let's take a look at that. So it looks something like this. So if I were to have an array of numbers, I have 5 numbers in there, 10, 20, 30, 40, and 50. Here is the for loop. I could have written it the other way that I was showing you before, but we can also do it like this. We say, okay, this VAL for value is going to actually print off each one of the numbers in there. So this is the name of the array here. So numbers is the name of the array. This is my new variable that I want to use that walks through the array. So it can be any name you want. And here it's just VAL for value. And it's going to be integers. So what it's going to do is it's actually going to walk through this array of integers. And it's going to pull each one out. So what's going to happen, you don't actually have an index number here that you're working with like you did with the for loop where you start at 0 and you count by 1s. It's going to do that for you. And so basically it's going to go through every number of the array and pull 1 by 1 through the whole array. And so when you say cout val, the first time through, it'll be the first value, then the second, then the third, then the fourth, then the fifth. And so it does that for you. The only thing this doesn't work for is if you actually need the index location. Like if you actually need to pull that index location, you don't have the index location anymore because this is just pulling the values. It just goes through pulling the values. It actually doesn't have that index or that subscript to pull. You don't have that counter variable that's gone through each time. Does that make sense, everybody? It's kind of a quick and easy way to do that, though, if that's what your goal is. Okay. The other thing is, it makes it a little more difficult if you want to modify something. So when we were using the for loop where we started at 0 and we went to the size of the array counting by 1s, you could modify it, okay? But if you're using that range-based for loop, then it makes it a little more difficult to modify because it's just using that value. you can't really modify. So we have to actually put this reference, remember the ampersand, on there to be able to modify. So this is an example. So we have a array size 5, okay? And you want, let's say that your loop, you're writing, you wanted to be able to put the values into the array, okay? So to put the values into the array, because you don't have the index location anymore, because you're using this range-based for loop, you're gonna see that this array here, this value that you're using to move through the array can actually be changed, okay? So when you put the ampersand there, that allows you to put the values into the array. That allows it to be changed, but if you don't put the ampersand, it won't put the values into the array. Not too bad, but just makes it a little more confusing. But that cuts down on having to write the full for loop. But if you use the for loop, you don't have to do like the reference like that. And then just to print them off, it's just like it was before on the previous slide. You just do that same loop here. You don't have to do the reference because you're not changing the values, you're just printing. So you only do the reference when you're changing it. You don't have to do that when you're printing it. Okay. Give a second to look at that and see if that makes sense. I think it's kind of a lot to process. Are y'all following along so far? Okay. All right. Anybody have any questions about that? Okay. All right. You can use auto as well. So this is the same example as before, except auto. Auto is a good way if you're not sure the data type or you want the data type to be able to be changed in the future, then you can use auto. Okay. So we were talking about this. You don't use the range for loop if you need the index location. So if you're trying to save the index location, you want to keep track of that. There's some reasons for wanting that. You can't use that, the range-based for loop. And then you have to make sure that if you're using the range-based for loop and you want to be able to modify the data in the array, you have to use that reference. You have to use the ampersand, like we just talked about. So some extra things you have to keep in mind. Okay. So when we're doing array content, something else to keep in mind is if you were to put like the post incrementation, this example, and you were to do it like this would actually increment the value in that index location. But this would actually increment the index. Okay, so if you put it inside the square brackets, it increments the index. If you put it outside, it increments the value. So be careful. Okay. Everyone with me? Same thing with the minus. Okay. If you want to assign one array to another array, you can't just put the name of the one array and the name of the other array and just put the equal sign there. Normally, when we want to assign something, we just put equals and put it in there. If we want to check something's equal, we put equal, but this doesn't work for arrays because there's more than one value. It's not just one value that you're putting in there, there's multiple values. So you have to go through all the values, putting each one into the array. You can't just say that one array, you know, you're going to put the value of one array into the other array because it's not just one value, it's multiple. So it has to go through each one. So you need a loop for that. And so here's an example of the loop, and it actually takes the index location 0 and puts it in the index location 0 of the other array, then the index location 1 and puts it in the index location 1, then index location 2 and puts it in index location 3. And whatever the array size is, it does one by one. And that's what's so powerful about loops and arrays, is this actually would be the same if you had 1,000 values in your array, and if you have 5. It would just, this variable, whatever's in this variable would change. But it's not like the program grows because you have more values, because this loop is based on array size and it works dependent, it doesn't matter what your array size is, right? That actually changes. And so, you know, in some aspect, it seems easier just to put values and variables and not use an array and not use a loop, because you don't want to have to understand the code. But if you understand how powerful it is, then it becomes so useful because you can access so many values and the code doesn't change much. I mean, it's a little difficult for us to understand, but it's pretty powerful then that you can change this, and this could be 5,000, you know, elements, and this doesn't change, right? Does that make sense, everybody? Okay. If you're using a character array, character is just one character at a time. you can actually say the name and it'll actually print out the whole character array, but you can't do that with a regular like string array or int array but just the character array. Otherwise, you have to go element by element and use the index location to move through it. So if you happen to use a character array, you can do that. Okay, so if you want to print the contents of an array, you're going to have to use a loop to go through them and print them one by one. Okay, so let me show you something quick to make sure this makes sense to everybody. I think I have, hold on here. Could do that. That works, I guess. I don't really use Visual Studio with you. I thought we upgraded to 2019. Okay. So here is some code that's going to have an array size of 5. Okay, so 5 integer values, and then it's going to have a loop. I usually use I because I stands for index, but you can use count or counter or whatever you want to use for that. And so what's going to happen is it's going to go less than 5 because that's the size, and you can use a variable here if you want to, so that if this changes as well. But this is going to go through and it's going to put those values actually 1 through 5 in there, so it prints those, and then it's going to print them. So if you see here, it actually puts 1 through 5 in there and prints 1 through 5. So if you take I and add 1, then instead of being 0, it would be 1, and then that's time to be 2 and 3 and 4 and 5. And then this, if you actually wanted to show you that if you put the name of the array, it doesn't print the contents of the array. It just prints the actual reference location. See, so if you put the name numbers, that's the name of the array. Here, it just prints the reference location instead of printing the actual values. So if you want to print the actual values, then you have to go through and use a loop to go through and actually print each index location of the array. I'm going to give you a second just to look at that and see if that code makes sense. This is how you put the values in. This doesn't really work because that gives you the reference location, and this is how you take the value, or this is how you print the values out. You put the values in and print the values out. And again, if you wanted to make a variable for the size, you could do that. So you could say like int size equals 5, and then put that here, here, and here. And then that way, if it changed, it would be more flexible so that I wouldn't have to go back and change those 3 spots. Everybody with me? That makes sense already? Do you have any questions? Okay. All right, so let's go back here. We'll talk about some more. Okay. So you can also use the for range loop to display the values. So we talked about this. So I can go through the numbers array, displaying value by value using the for range loop. If you want to do a sum, keep track, and do an average of scores that you're working with, what you can do is you can, again, your loop looks the same here, but when you're doing it, you just go and take whatever one you're on. If you're in index location 0, when you start, you add it to the sum. So remember, you put plus equals. So sum plus equals this, and start your sum at 0. We'll take whatever index location you're on and add that to the sum. And then the next time when the t-num changes, then that will become 1. And then this time you'll take that one and add it to the previous sum. And then when that becomes 2, you'll take that index value, that element that's in that index location, and add it to the sum. And then when your index changes again, you'll take that one. Does everybody see how that works? And then when you're doing the average, you just divide by how many you have. So if you have a size of your array, then just divide by the size of the array. So if you have 5, it'll divide by 5. And if it's 10, it'll be 10. And that's actually not on here. The array actually isn't on here. But it would work for any array size with any elements in there. Everybody with me? Okay, any questions? All right. You can use the range-based for loop the same way. And so here you can take the value and add it to the total. And then actually, instead of doing the starting at 0, adding by 1s, going the size of the array, this works the same way. This actually will do value by value in your array. And then you know the size of your array, or in this case, it says the number of scores. So just divide by the size or the number of scores the same way you did before. Now, in this code, you see how this doesn't have curly braces around this for loop? Only this one line, you can see the indentation of it. Only this one line is included in this for loop. So it actually wouldn't include the average until after it's done. And most of the time, you don't want to do the average until after you've gotten the total for all the scores, because then you can divide by the total number of scores and get the final average. Because if you do it inside the loop, it'll divide it each time, and you'll get an average that is not complete yet because you haven't completed all the scores. So this actually is outside the loop. You could still put the curly braces on there, but this wouldn't be included, this average. Everybody with me? Okay. Now, what if you want to find the highest value and the lowest value? We'll talk about the lowest in just a second. The lowest, if you know the highest, the lowest, it's just, flip the sign really and change the word highest to lowest. But let's talk about this. So we're going to have a variable for the count that works through the loop. And this loop looks the same. So when you're working with the loop, actually, where does this one start at? 1. I guess, yeah, okay, let me talk about this for a second. So you could start with 0. It really doesn't matter if you didn't want it to be tricky. So here we have this variable called highest. And highest is going to be numbers index 0, okay? So numbers index 0 is the first number of your array, right? So whatever value that might be, that's the first number of your array. So it's going to put that in your highest variable, okay? So I know you probably don't do this when you're trying to figure out what the highest is, but let's say you had a list of numbers. You had those numbers, right? And you wanted to know what the highest one was. Well, what we're going to do when we're trying to logically figure this out is we're going to look at the first number and we're going to put that in highest. So we have this variable called highest, okay? And we're going to put 10 in there, okay? That's what it's doing. It's taking the first one and putting it in there. Everybody with me? Then what it's going to do is it's going to start the loop at 1 because it already accounted for the first value. That's already in highest. So you don't really need to do that again. Now, if you do it again, it's not a big deal. If it's confusing to start at 1, because normally you start at 0, it's just that you don't really have to start at 0 because you already put that value in here. So for comparison's sake, if you start at 1, you're going to actually look at the 30 instead of the 10. So what's going to happen here is it's going to go through, but it's going to use this value, the one at index location 1, which is 30. And so when it says numbers count, that's actually going to be 30 in this case. And it's going to say, is that greater than highest, which is 10? So is 30 greater than 10? Yes. Okay. So what's going to happen is it's going to take that number, numbers count index 1, which is 30, put it into highest. So it wipes out this 10 and this becomes 30. Okay. Then what's going to happen is it's going to go back and increment count. So again, maybe let's start this again so you can take a look at this. Let's say these are my numbers. This is my array. Okay. And then we'll put this count equals 1. Okay. So when we get to the loop, when we do the count, we're going to do it the first time, and it's going to see the index 1 numbers, index 1 is 30, and 30 is greater than 10. Okay. So it's going to say take numbers index count, which is 1, which is 30, and put it into highest. And so it's going to say, okay, take this 10 and put 30 in there. Okay. Then when you increment count, count is going to become 2. Okay. So then it's going to do it again. It's going to say take numbers index count, which is 2, right? And so that's actually this one, right? Take 50. Is it greater than highest? So is 50 greater than 30? Yes, right? Okay. So then take numbers index count, which is 50, and put it in highest. So that becomes the new one. Okay. Then go back and increment count, so it becomes 3. Okay. Then go to numbers index count, which is 3, which is this one. Remember, it's 0, 1, 2, 3, right? It's this value. Okay. So now we're going to compare this value here to highest. Is 5 greater than 50? No, so don't do that. So it stays 50. So when the loop is done, it's 50. So what's happening is each time through the loop, it's taking and comparing the current value that you're on, right, with the number that it previously had as the highest. And if it finds one that's higher, it replaces it. Okay. And when you get to the end, the value that's in highest is the highest value because you replaced it each time. So what the book is showing you is you don't need to start at 0, because if you put the highest value as the first value of your array, like this line here, see this line here, highest equals numbers index 0. If you put that as your highest, then you can start your count for your loop at 1 because you already have highest of 10. If you start your loop at 0, it's not a huge deal what happens if you're not sure. What happens is when you do it, when you say numbers count 0, it's going to take 10 and compare it to 10, which 10 is not higher than 10 because it's the same number, because you put that first number into your. Now, when you're doing highest, a lot of people will use the first number as the highest, and they don't actually put the number in there. They put the index location of they put the array in the index location, so it pulls it. Because if I were to put 10 in there, if I were to say highest equals 10, like I do here, I'm just putting the actual value in there that it equates to. Then if I change the values, it wouldn't update that, right? Okay. What's wrong with putting like 100 in there? Just randomly putting 100. Well, then nothing's higher than that, and 100 would be 100 at the end, right? So what if I just put 0 in there as highest is 0 instead of numbers index 0? That would probably work because most values will be greater than 0. But what happens if you have an array of negative numbers, which you can have? Typically you don't have an array of negative numbers, but you might have an array of negative numbers. And you said your highest was 0. Well, then 0 will be the highest because all the negative numbers won't be higher than it. So you don't want to, what I'm basically saying is you don't want to arbitrarily pick a value for highest and have it end up being your highest because nothing in your array is higher than it. So when you're setting your highest here, most of the time people will pick a value in the array, and picking the first value in your array makes sense because you don't know how many values you'll have. So you don't want to pick like the 5th value in your array because you don't know if you'll have 5 values. Okay. So picking the first one, you can't have an array with no values, right? You're going to have at least one value. So pick the first value because you know you at least have one. It's not really an array if you don't have any values, right? You're not going to have an array size of 0. So you know you're going to have an index location 0 because that's the first value in your array. So a lot of times for setting the highest or lowest, instead of putting an actual number in here, like I know a lot of times you say sum equals 0. Well, that's because you haven't summed anything yet. That makes sense. But when you say highest equals 0, a lot of times it'll work because a lot of numbers are higher than 0, right? But if you end up with an array of negative numbers, that's not going to work, and that's going to mess up your highest. You want to use the first value in your array, because if you use a value in your array, then when you do the comparison, it has to be something you're already comparing that's already in your array. You're not just arbitrarily picking a value, right, to compare it to. So I'm starting with the first value, and that's why the loop starts at 1 instead of 0. Now, if you started at 0, it's no big deal. It's just going to go through one more iteration that it doesn't need to go through because you already took the first value of the array and you already have that in highest. So you don't need to compare it to that because you already have it. But just the way that this is written, does that make sense to everybody? Are y'all okay with that? Do you need some more explanation? Or because you're going to have to do something like this for your assignment. And you should understand this. This is very common. Finding the total, the average, the highest value, the lowest value is very common when you're first starting off with programming. Okay. Okay, so if you can do the highest value, you can do the lowest value. So the lowest value, again, you don't want to arbitrarily pick a value. If you pick like 100, most of the time values will be less than 100, like if you're talking about scores. But what if you're not talking about scores and all your values are in the thousands? Then that's not going to work because that'll be your lowest value. So you could technically pick the highest value that exists for an integer. That's one way to do it. Okay. Then every value has to be less than that. Okay. Or you can pick the first value of your array. Okay. And then it'll work because it has to be a value in your array. So you can either pick the first value of your array, or you can pick the highest integer value there is. because everything has to be less than that or equal to. Okay, so those are your options. And with the other one, you can pick the first value array or you can pick the lowest possible integer value, and everything has to be higher than that. Okay, and I don't offhand know what that is, but you can look it up. You can look up what the lowest possible integer value is and type that in if you want to. And the highest, or you can just pick the first number in your array. So the same thing, start at 1 because you're putting the first number in here this time, but don't normally start your loops at 1 if you're working with an array. It's only because of the way this is written that works. And if you're confused by that, just start at 0 because it doesn't really impact it enough that you need to change it. Okay, so it's instead of doing greater than, you're just doing less than, and just change highest to lowest. It's the same exact thing, except you're seeing which one's the least. So when you go through those values, like if I was doing the values I had here for lowest, I would do the same thing. I would put the first value of the array in there, which is 10. And then each time I go through, see, I'm starting at 1 again here instead of 0 because I already did that. I already handled that with this. Then I'm going to go through because that's true. I'm going through and saying numbers count for an index. And so the index of 1 would be this one here, which is 30. So I would say 30 is less than lowest, which is 10. So 30 is not less than 10. So I wouldn't do it. And then I would go up and increment count. So it becomes 2. That moves me to this number. So then I say 50 is less than lowest, which is 10. And 50 is not less than 10. So I don't do it again. I increment count and I go to 3, which is this number. This number says 5 is less than lowest, which is 5. 5 is less than 10. So because 5 is less than 10, I am going to replace lowest in that particular case. So when I get to the end down here, if I were to print the lowest number, then I would have 5. Be careful when you're doing this that you don't declare the lowest variable in your loop, because if you try and print it outside your loop, you'll have problems because it's local to the loop. So you want to declare your lowest variable above your loop so that if you wanted to print it after your loop, you'd be able to. If you declare it in your loop, you won't be able to. Everybody with me? So you got to be careful of when you declare local variables because they're only local to that particular thing that you're talking about and they don't know about it in the other part. So you want to declare it up above the loop. Okay, any questions? You know how to do total? You know how to do the average and how to do the highest and lowest? Okay. All right. So we talked about this already. So if you don't fill in all the values, it automatically fill in 0 for the rest of the values if you have a partially filled array. But you have to be careful. You know, it's always better to have more than not have enough, right? Because we talked about what happens if you have a size of 3, but you try to put 5 values in there. It creates all kinds of problems in your program. So it'd be better to have a size of 5 and only have 3 values than a size of 3 and try and have 5 values. Always, in most cases, it's better to have too much than to not have enough, right? Just think about most of the situations out there, right? If I were bringing in copies of something and I thought I might have 25 people, I wouldn't want to bring 20 copies, right? That wouldn't work too well. So I'd probably bring 30 just in case, right? That way, if I have 30 people, I'm good. Okay, everybody with me? Makes sense? All right. When you're comparing two arrays, let's say we have this first array and we have the second array, we want to know if they're the same. This is kind of tricky. Let me make it so that we're using the full screen here. So when we're looking at these two arrays, we're going to use a loop. And what's going to happen is if you look at this if statement for just a second with me, when you're going through the loop, you take the first array count, and you're going to increment the count, even though it's using a while loop. So let's say that the count is going through and starting at index location 0, and then 1, then 2, then 3, just like we're used to. So if we're trying to compare first array count to second array count, let's say they're at the same count, right? The same variable. If you say not equal, remember the exclamation point means not. So exclamation point equal means not equal to something. So if you say this one is not equal to this one, then we're going to see this variable here. It's a Boolean variable, arrays equal equals false. Because as soon as we hit a value that's not equal, we're going to go ahead and set that variable as false. Now, if one of the values is not equal, then we know the arrays aren't equal, right? As soon as we find a value that's not equal, because every value has to be equal for the whole array to be equal, right? So at the beginning, our array's equal variable is true. Okay, so we call that a flag because you can take a flag and set it to true, and if it becomes false, we know that something happened, right? Or vice versa. But in this case, we set it to true, and if that variable gets flipped to false, we know that we found a value that wasn't equal. Okay, so what's happening in here is we have this while loop, and while array is equal, that's true. You don't have to say equal equal true because automatically, if you say array is equal, if it's a Boolean variable, that means equals true. Okay, so while array equals, that means while that's true, while that variable is true, and it's going to be true the first time, so we're good. And the count is less than size, so size is 5. So whenever count is 0, we have count up here. So as long as 0 is less than 5, which is true, we're going to go ahead and do this loop from here to here. Okay, so we're going to go and do this conditional. Now remember we just talked about this conditional. This conditional is going to compare the count, which starts at 0, of this array and the count of this array. So it's going to take the index location 0, which is 5, and the index location of the second array 0, which is 5. So it's going to compare 5 to 5, right? If 5 is not equal to 5, which they are equal, right? So we're not going to do that. Okay. Then we set this at false, but that's not true. So we're not going to do that. Okay. Then we're going to increment count. So we move to 1. So first we were 0, then we're 1. So when we move count to 1, this is still true because we didn't set it to false. And then this just is still true because we're only on the index location 1, the count 1. So now we move to the value of 10. So we're going to check 10 and 10. Now these arrays happen to be equal. So we're actually going to go through each of these and this isn't going to match for any of them. But if one of these values were different, that's when you would make this actually so that it's true because they're not the same. And you would set this at false. And if this becomes false, this loop stops. So, you know, if you hit the first value and they're not equal, you don't have to continue the loop because there's no point in checking through all the other values, right? So as soon as you hit a value that's not equal, it sets this value at false and that loop doesn't continue. Okay. Now what happens down here? Well, if arrays equals is true, it doesn't have, you don't have to say equal equal true, but you can if you want to. Then it says they're equal, otherwise it says they're not equal. In this case, they are equal, they're all true. So you never actually set the arrays equal to false. So the loop actually had to go through all the values and it never set it to false. So it is going to say they're equal. But if one of these values were different, then this would set it false and it would say they're not equal. And whenever you hit that value, it wouldn't continue the loop anymore because this would be false. And so it wouldn't continue the loop. I can give you a minute to just look at that and see if that makes sense to everybody. Because I know that's a little complex. And so if you have any questions, let me know. Everybody with me? Okay. All right. So we're going to get a little more advanced if you're all okay so far. Everybody okay?
Okay. It's a lot to take in.
It's a lot to take in, I know. So make sure that this week you really have a chance to read the chapter, okay? Because next week when you come in, I want to answer your questions. If you have questions, and I want to show you some examples, and if you have questions for me, I'll try to have various examples I can pull and things we could talk about. So we have 2 weeks for this chapter. So this week, really make sure that you have a chance to really soak it all in, basically. And then next week is when we can dissect it a bit more and talk about what you maybe had questions about before you have to do the assignment and everything. Okay. So I know you have to kind of take it in. So if this is the first time hearing it, if you didn't get a chance to read it, it might be a lot. But once you read it, I hope it'll become a little better. And then once we review it, it'll become even better. That's my hope. So if you hear it a couple of times, it'll become better. You practice with it too. So you know what parallel means, right? Side by side together, right? Okay. So a parallel array, you can have 2 arrays and they work together. Okay. So what's the purpose of that? If you have related data, so we're going to show an example of like a student ID, an array with the student IDs, and then like scores, okay, of students, you know, that have those IDs. So you can have 2 different arrays that hold 2 different sets of data, and they don't have to be the same type. So like I can have an array of names, and then I can have the data that goes with those names in a different array, okay? Because we know the array can only store the one data type, right? But the way that you can actually make the arrays work together is if you have 2 arrays and the first name has an index value of 0, and then the score that goes with that name has an index value of 0, then they go together, right? because you say the index, sorry, index location 0 will be this particular student, and index location, 1 will be this student, and 2 will be this student, and 3 will be, okay? So that's how we relate them to each other. So we can have different arrays. So in this example, we have an average array, and then we have a grade array, okay? And so we have this for loop that looks the same as before. Start at 0, go by 1, go the whole length of the array, which is size of 5, okay? And they're both going to have a size of 5, so it makes sense that they're the same length, right? And here we're going to have another array called ID, okay? So the student ID is going to be linked to the average and the grade, okay? Because they're all going to have the same index value, okay? And here's another example. This one has number of employees 5. How many hours did they work? That's an array. And what's their pay rate? Okay. And so the number of employees is going to be the size of the array of 5. And they're both going to have 5 because the hours and the pay rate will be linked together. Okay. It's going to be our 2 parallel arrays. And so when you're entering it, you enter the hours worked for the employee. Okay. And then you enter the pay rate for that employee, okay? And it goes into the same index number, the one array and then the other array, okay? So that when you pull that index number, the hours that the employee worked and the pay rate for that employee go together, so you can do an equation with them and figure out how much they made, right? Okay, so why does it say index plus 1 here? That's just for output to make it look good, right? Remember I talked about this before. You can't say hours worked for employee number 0 because that looks weird, right? Because people don't start counting at 0, and people that don't know how programming works, they don't know that the program starts at 0, and they're not used to that, and that would look weird. And so we start at 1, right? So we add a 1 on there, but we don't actually change the index. We're just changing it for display purposes, okay? So we can see here that here, when you're printing it off, you can use that same index for the actual hours and the pay rate, and you multiply them together, then you can get their actual pay. So those are 2 parallel arrays. One's holding the hours, one's holding the pay rate. So you can enter, see how it says hours worked for employee number 1 instead of number 0, because we added the 1 on there to make it look good. Okay. Y'all with me? Does that make sense, everybody? Do y'all have any questions about why that might be useful or how that works? If you understand how the index values work, then it's just 2 arrays with the same index values. So this array is holding this data and this one, and the way that they're linked together is you use the same index number for both to access them so that you can relate them basically. Okay, so you can see how they're linked. This one has the same index number and the same, so it goes together. This is employee 1, employee 2, employee 3. Everybody with me? Moving right along, slide 53 out of 84. Okay. Arrays as function arguments. If we don't get through, we'll finish next week, but I think we're good. And then we can see some examples next week. Okay, so we talked about functions, and hopefully those make sense because we had some practice on the discussion board and assignments and review questions. I hope that they make sense. And if functions aren't making sense, please make sure you see me so that I can help you with them, because you will have to know how to do that. Okay. So if you're using an array as an argument for a function, I want to talk to you about how to do that. So here we have our function header. Let's take a look at that first. So we have a show scores function, right? And this is where you have to write out the full parameter. Okay, we talked about this. So what's the variable name and what's the data type? You have to write it out completely. So here we're going to have a test array that's an integer. Okay. Now, when you do the prototype for that function, you don't have to put the name of the array. Okay, remember you just put, now in this case, you're going to put the brackets so it knows it's an array. So integer, and you're going to put the brackets so that you know that you have an array. Okay, but don't put the name of the array. Remember, the prototype is just to let C++ know that later you have a function that's going to have those, data types for the parameters, letting it know that that function will be in there, but more details when you actually do the header itself. Okay. Now, when you call it, when you pass in an array, you don't put the data type of the array and you don't put the array brackets, you just put the name of the array, past the array. But when you're doing the header, you do put that it's an array and what data type it is. But when the array actually comes into here, you don't put up here when you call it, you don't put the square brackets or you don't put the type because it already knows that. It knows that test is an integer array and it has the values for it, hopefully, and that's what's going to be passed. Okay. Everybody with me? So far, so good. Okay. Now, when you're doing an array, it's also common to pass the array size. So you can also put another parameter on there that takes in the size. So down here, when you do the header, you're going to put what data type that is, which size is going to be an integer because it's going to be a whole number size. And then here you don't put the variable name, but you do put that it's an integer. And then here you're actually going to put what the size is, whether that be a number or that be a variable that represents the size. That value is what's going to be passed to the size down here. Everybody good? Okay. So here's an example. You have an array size of 8. So here are the 8 values for your array. So you actually initialize it up here. Here's the loop. This is a standard loop, going to look the same unless you're going to use the range-based for loop. This is a for loop, starts with 0, goes to the size of the array, and increments by 1. So this is actually in a separate function now. See how there's a separate function? This is main up here from line 7 to 14. This is a show values function from line 23 to 28. And so if you're going to use the array that you have up here, down here, you have to pass it in. Okay. Now, when you pass it in, here it's called nums. Okay. Up here it's called numbers. Okay. And then here I'm also passing in the size. Then you can just display the values just like you normally would once you have the actual array. So here, this loop looks the same, and this it's just moved down here. So you have to do a little more work because you have to pass in the array and you have to pass in the size. Okay, so when you call it, you're just going to put the name of the array, which is numbers. You're not going to put that it's an array or what the data type is because it already knows that from up here. And then what's the size from up here? So I know this is kind of basic because you have these numbers in this array and you have the separate function to display it. Yes, you could have just done that up there, but this is just to show you how you can pass the array and the size to a separate function in case you did need to. In this case, you probably shouldn't. You would just do it up here, but it's just to show you how you can do it. Okay, does that make sense? Doesn't seem that useful, no. You could probably do it up in the main function. Okay. So when you're working with integers and doubles and everything, and you're doing a function, you're calling a function, we talked about this before. If you're passing by value, okay, when you do that. And if you want to pass by reference, you have to put the ampersand, right? But when you're working with an array, you're actually passing by reference by default, okay? So if you pass an array, you change the array and the function that you have passed it to, you're actually modifying the original array, okay? So what if you don't want to modify the original array? If you modify the array in the new function, you're actually going to put CONST, which stands for what? Do you know?
Constant.
Constant, perfect. And constant means it can't be changed, right? So if when you're passing it, if you put in the parameter that is constant, it won't change the original array. So it works a little differently because you had to do extra work when you're passing by value. If you wanted to make it actually change it, you had to put the reference, you had to put the ampersand. But now, this time with arrays, you have to actually go the opposite and put constant if you don't want it to be changed. So, you know, arrays will actually get changed because they're by reference, because arrays are actually objects. Talk about that in your next class, what exactly an object is. But arrays will actually get changed. They get passed by reference. And the other values we were talking about get passed by value. Okay. So the other way we had to do a little more work to get them to be passed by reference. This way they're passed by reference, and you have to do a little more work to get them to be passed by value. So they won't change. Everybody with me? Okay, depends on what you're trying to do. Okay. Anybody have any questions so far? I didn't have that on the slide, but remember you have to put constant. Okay. So if you don't want your original array to change, you would have to put constant here, CONST. So you don't want the original array to change. Now in this case, you're not changing the array because you're just printing. But if you were modifying the array, you'd have to be aware that you're actually modifying this array. Okay. Even though they don't have the same name. That original array gets modified, but it's not getting modified here because it's just getting printed. But if you were going to modify it, you would want to put CONST there so it didn't get modified, the original array, if you didn't want it to change. Any questions? So excited, you want to learn more. I can see it.
Typing this while like programming this will be like kind of complicated, like not easy.
Yeah, it's going to take you a bit. So make sure you spend this week really reading this chapter, please. And if you're behind, it would be nice to jump to this chapter, but I would say let's get caught up with the other chapters because you really have to know what a loop is pretty well before you can do an array. So we really have to get caught up on that. If you're confused about loops, you can see how now you can't do an array without a loop. So that really puts you in a predicament. If you go to do the assignment and you don't understand for loops, you can't do your array because you can't do the loop. And it really just kind of adds up and adds up. So the more that you can get done to get caught up if you're behind on your reading would be beneficial to helping you understand how everything fits together. So please try and set aside some time for that or get some help if you need it. I'm here to help, Matt's there to help. So please let us know if you need some help. Okay. If you understand one-dimensional arrays, hopefully two-dimensional arrays aren't that bad. So a one-dimensional array would mean, let's say I wanted to take one student's scores and take the average of their scores. That's a one-dimensional array, right? That's what we've been talking about all along, actually. But what if I wanted to take the class, the whole class, all of the students in the class and all of their scores? Instead of putting that just in a row or a column, now I have a table that I'm thinking about, right? Okay, so I, for this class, use a grade book, right? In Canvas, you have a nice little grade book. And in my grade book, I have multiple students with multiple scores. But in your grade book, you only have you with your scores. So yours is a one-dimensional array. My grade book is a two-dimensional array because I have multiple students with multiple scores, but yours only has one student with multiple scores, right? Okay, so mine looks like a table. Yours just looks like a row or a column with all your scores, right? Okay, so you see the difference? So when you did back when we were doing loops, we did nested loops with a loop inside a loop. And we did this printout of asterisks. And I had you print, like I said, okay, what if you wanted to do a 10 by 10? Okay, and you wanted to print asterisks. And this was one of your review questions that you did. So hopefully it made sense. I said, okay, what if you wanted to do that? How would you do that with nested loops? Okay, so you'd have to go through and do the one loop inside the other loop to print the asterisks the way you want it. Well, this is kind of the same thing you want to think about. So when you have a table, think of like that spreadsheet, that table where you have multiple students with multiple scores. So now you have rows and columns. Instead of just a column or a row, you have rows and columns. Okay, so now you have two square brackets and one handles the rows and one handles the columns. Okay, everybody with me? All right, so it looks like this. So instead of just having one index location, you're going to have two numbers that represents the index. Okay, so we still start with 0. So the first score, like if you're talking about scores, would be at 0, 0. So 0, 0 is the first score. That's the first one in your, so think these are the columns, right? And these are the rows. So in column 0, row 0, that's the first score. Okay. And then in row 0, column 1, that's the second score. And in row 0, column 2, and in row 0, column 3. Okay. So if you were doing this one, if you wanted to put a score in a particular spot in the table, you'd have to say which row, which column. Okay. Everybody with me? All right. So let's say we had divisions and quarters. Okay. And so, and it doesn't have to be the same number. See how there's 3 divisions, but 4 quarters? They don't have to be the same number. Okay. So how do we do this? Well, we have an outer loop here. See the outer for loop, and we have an inner loop here. Okay. So the outer loop, again, your loops are going to start at 0 because your arrays start at 0. So your outer loop starts at 0, your inner loop starts at 0. But what happens is you have to finish the divisions before you're going to go through one division and finish the quarters before you go to the next division. So I want you to look at the output for a second. So you're going to finish the division, or you're going to work with the division and finish the quarters for that division, then go to the next division and finish the quarters, then go to the next division and finish the quarters. And I kind of mentioned this, but I like to go back to this because it kind of makes sense, everybody. Again, if you think about if you've been to Six Flags and you rode that teacup ride, and I talked about this before, I know, with the inner loop and the outer loop, but think about that teacup ride, because I hope it makes sense. Y'all know what I'm talking about, right? The teacups that spin.
Is it the, when you mean teacup ride, is it the one that goes in circles?
Yeah, the one that goes in circles, and they have it at like Disney, they have it at Six Flags, but the one that makes you really dizzy, right?
Oh, yeah, that one.
So there's an outer platform that spins, and then there's a teacup that spins as well. Okay, the individual teacup. Now I know some of them you can turn and make it spin more, but let's pretend you can't make this one spin more. It just spins a certain number of times. So for every outer loop that that ride has to go on, the individual teacups will spin a certain number of times. And so think of that how that works with how this works. So this, you're saying, okay, you have division 1, for example. So we're going to handle all the quarters for division 1 before we enter anything for division 2. So when you think about your loops, what's going to happen is the division is going to be the outer loop, okay? And when you're on division 1, you're going to go through the inner loop 4 times for division 1, okay? Entering the data. And then you're going to flip the outer loop to division 2. Then you're going to go in the inner loop 4 times for all the quarters. And then you're going to flip the outer loop to division 3 and go through all the quarters. So basically, you have to finish all the inner loops before you can go back and flip the outer loop. So if you think about the teacups, your individual teacup is going to rotate, let's say 10 times for every 1 time the outer loop goes through. So the outer loop is going 1 time, and it's going and it's going and it's going. But each time as it's going around, you're also going 10 times as it's going around. So when you get back to the same spot you started at with the outer loop, your teacup is rotated 10 times, right? And then it goes back around again and it rotates 10 times again. And when it goes 1 more revolution around, and then it does it again, and I don't know how many times it goes around, but just think every time you're in the outer loop, you're going to increment, but then you're going to have to finish the inner loop before you go back and increment the outer loop again. So just think about this, okay? We're in division 1, have to finish all the quarters. We're in division 2, have to finish all the quarters. In division 3, have to finish all the quarters, okay? So you can write it different ways, okay? I mean, you could have went across a different way and did all the quarters for all the divisions, and then did all the quarters for all the divisions, but just however you think about it. But however you write your loops, so see this one does, the outer loop does the divisions. See, it starts at 0, and then it goes, as soon as it does it, it's going to go in and do the quarters, and it can't get out of this loop until it finishes all the quarters. So this is still division 0, right? Okay, but we call it 1, right? Just to make it make sense when people are looking at it. So here we add 1 to it to make it do division 1 instead of, but it's really division 0. And then you're going to do quarter 0, 1, 2, 3, which really we print 1, 2, 3, 4 because it looks better to the person entering the data. So we're adding a 1 on here just to make it look better. But really, you're having to do each quarter and enter the data before you can flip to the next division. Does that make sense, everybody? I think the best way to kind of understand this is to maybe type in this program and change the number of divisions, the number of quarters, change what's printing to see if you can see what's going on here, because it's kind of hard to envision a 2-dimensional array, but hopefully you understand the point of it and how it kind of works through. If you had an easy time with the grid that we had with the asterisks, then this should make sense because this is the same idea. Trying to print the number of columns and rows for this is the same as doing the asterisks with the grid. But if that was hard for you, if that was really hard, then this is going to be hard as well. And we need to really practice for loops. If that is, we need to go back and practice for loops. But hopefully the array is not too bad. It knows which value, index value, based on your variables you have here, then moving through your loop. So that's how you have the div for division and the qtr for quarter. So really spend some time with that this week. If you're having trouble with it, maybe type in that program and play around and see what's printing out and see what's happening and see if it makes sense. Try and add your own and try and change the number instead of having 3 divisions and 4 quarters. Try and change that. Try and change the names to something you want. Try and change it to students and scores. See if you can make it work and see if it makes sense to you. If you have some time to play with that. Everybody with me? I know this is going to be hard and this is a lot to go through, but I really need you to make sure that you're reading the chapters and practicing the content in there, because if you're skipping that and just trying to do the assignments, it's going to be hard. You really need to practice those checkpoints and make sure you're reading, because that's going to make it a lot easier, because just hearing it once in class is not enough. You really need to read it and practice with it to get it. I don't expect anyone to hear it once and be perfect with it and be able to do the assignment. The only way you're going to get it is to go back through it and make sure you're reading it. So that's why I give you credit for reading it, because I think it's really important, because I've noticed in past classes, the students that don't get a chance to read it, it doesn't really sink in, because it's like they only hear it one time, they try and do it, they don't work with it, they don't get practice with it. It's not enough, right? It's not enough to hear it once or twice a week. Okay.
Do you know how long it will take to read the chapter 7?
Probably a couple hours. Does
Yeah,
anybody want to give an estimate? Maybe.
It took me 6 hours for half.
Did it? Okay, it takes a long time.
oh my gosh.
A long time. So set aside some time. Yeah, it's and doing the checkpoint questions takes a little longer. But that's really how it's going to sink in, because me just telling you one time it's not going to work, especially with it getting this complex. Maybe at the beginning that was enough, but now I think in order to really learn it, you're going to have to.
Could we skip like the checkpoint questions to save a little time?
You won't get credit for them if you do.
But do we still get credit for reading them? Or
No, the checkpoints where you get the credit. I mean, it'll tell me how long you spent on each page reading it, but it doesn't really give credit for that.
Alright.
So it's the checkpoints that you should be able to answer those kind of quickly if you read it. Hopefully, it's just when you get stuck, if you really want something specific and you feel like you put that answer, but it's not accepting it, let me know, because it might just be, we might just have to switch it so that the system accepts it. That's one thing that's bad about systems that do automatic grading, is sometimes if you don't do it the exact way that it's asking for, even if your way works, you just have to alter it a little bit to make it accepted.
yeah.
So let me know if you're having that trouble. Okay, so you can do, just like we did our size declarator, you can put variables up here that represent the size of the rows and the columns. So this is a 2 by 2, so you have this little table 2 by 2. And then this is how you would put the scores in there. So it looks a little different because you have the curly braces in there and you separate by a comma. And then this is how you get the values, the 84 is 78, and then the 92 and 97. So you do a row, and then you do all the columns for that row, and then the next row and all the columns for that row. Everyone okay? Okay. Then when you're doing it, and we already talked about this, instead of using like the square brackets, you just put the array name when you want to pass it. So when you're doing it down here, you can, just like we did before, you can put the size of the rows, but then you want to put the columns in here for this one. And then this one you can leave blank for the prototype, but just put the column size in there. It looks a little different for a 2-dimensional array because you don't have to put the row one in there, but you want to put the column one in there. Okay, so here's an example. You have an outer for loop and an inner for loop. So you have the rows and the columns. So again, start at 0 because you want to make sure you start at 0, 0. So we do the rows and then we do the columns. So we're going to do row 0 and we're going to go through column 0, column 1, column 2, column 3, and then we're going to flip back to the outer loop and go row 1, and then we're going to go column 0, column 1, column 2, column 3, column 4, and then we're going to go row 2, and then we're going to column 0, column. We're going to do all the columns. Okay. So each time we're going to reset the columns, but we're going to flip to the next row. If that makes sense. Okay, so this is one way to get the data in here. So you can see we're doing, this is a row and this is column, 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 row, column, 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 column. Okay. Hopefully the idea of 2-dimensional arrays makes sense. We do a lot of 2-dimensional arrays. The thing that we don't do as much of is 3-dimensional arrays. But we can have 3-dimensional arrays. So if we talk about 3-dimensional arrays, for example, that would be if I had a bunch of students that have a bunch of scores across so multiple students with multiple scores across multiple semesters. Okay, so like in Excel, I normally, or maybe across multiple sections, you could do that too. Okay, and then we could do 4 dimensions across multiple semesters. We could keep going with it. But in Excel, for each of my sections, I'll have a sheet, and the sheet has the students and has the scores. But then I'll have my other section that has students and scores, right? Okay. So here we just have another example of the 2-dimensional array. Again, the biggest thing is understanding how the inner and outer for loop work. So if you have trouble with that, I think the best way is just to experiment with it a bit. Go into like online GDB or C++ shell or even Visual Studio if you want to, and kind of try to create your own two-dimensional array and see if you can work through it. See if you can put values into it, take values out of it, total them. So if you want to sum all of the elements in a two-dimensional array, then you want to put that total in here, and you have to actually work with the row and the column on your array. Okay, so this does the total for all the scores. So if you had a table with a bunch of students with a bunch of scores, this would total all of their scores for the whole table, right? But what if you didn't want to do that? What if you wanted to just sum the rows? Okay, so here you can see that if you're just summing the rows, you actually are going to go through and you're going to work with just one loop. Okay. And you can go, I know it's weird because it has column and you're doing the row. That's because for that particular row, you have to sum all of the columns for that row. So when you're working with a row, to move to the next score, you're actually switching the column. So think of it as like the first score is in column 0, and the next score is in column 1, and the next one's in column 2. It's just a row with a bunch of scores, but you're switching the column to get to the next score. That makes sense, everybody? And then you can average that particular student's scores, because we'll say that a row is a student scores, and when you're in column 0, that's their first score. In column 1 is their second, column 2 is their third. Okay. And then what if you wanted to sum the other way, sum the columns? So let's say you wanted to get this, you wanted to get the average for the first test in the class. Okay. So we want to get the test average. And so what we would do is, instead of switching columns to get all the scores in the row, we would switch the rows. Okay, I know this sounds odd, but think of that table again, right? And instead of having the students' names as the rows, you have the test scores at the top, right? So are you all following with me? I have my nice little table. Let me go back for a second. I don't know if I'm losing. I should have created a table. So these would be the students' names, right? And these would be the tests, like test 1, test 2, test 3, test 4, right? So if I want to do the students' names, those would be the rows. You have to go through the columns to get out their scores, to get their average for that student. So think row is the student name, right? Are you all with me? And so you would go through the columns, you would switch the columns to get their scores, right? To get the average for that particular student. But if the columns are the tests, like test 1, test 2, test 3, right? Then you would switch the rows to get the average for a test. So for if column 0 is test 1, for example, I would have to go row 0, row 1, row 2, and at the end get the average for that particular test. That's what I'm trying to do here. So if you look at this, and at the top it tells you, if you're going through these later, these PowerPoint slides, I posted them on Canvas if you wanted to look at them, and the examples are also in your book. And if you type them in and have any trouble, let me know. But here is here's the one. So when you're doing this, when you're doing the column, you're getting the test score. So I was saying the test, you're going through the rows. Okay. It sounds like, okay, if the students' names are on the rows, then I would switch the rows, right? But then that would switch the students, not the actual scores. So you want to do the opposite. I know it sounds kind of strange. If you're doing the names of the students, then you want to switch the columns to get through, and then to get all the scores for all of theirs. So remember, if we have test 1, test 2, test 3, you have to go through test 1, then test 2, then test 3, and those are the columns, not the rows. If you're talking about that, maybe I can draw a little chart for next class just to make sure everybody understands that, and go through it once with you if you're having trouble. And then I mentioned this, and I think everyone's getting kind of burned out, and we're towards the end here. So I'll just finish this last bit. We'll talk about vectors next week. Give you some time to study with just arrays. Vectors are arrays that can basically change size. Okay, so they're a little more flexible. Okay, so there's only a few pages on vectors. I think there's like 5 pages in your book on vectors, but I think you've probably had enough at this point. Maybe no rest. So maybe vectors could be a next week thing. We need to focus on arrays at this point. If you can get through understanding arrays this week, vectors are easy and we'll worry about those next week. Those are just a little side note to the arrays. But we don't really work with 3 dimensions in this class, but you should know what they are. So 3 dimensions, you can actually have as many dimensions as you need, but you just have you add more brackets, right? Okay. But anytime you add another dimension, you add more complexity, right? So of course, it's gonna be a little more complex. So it's a lot easier to work with one-dimensional arrays, gets more complicated to 2, and then 3 are harder, and 4 is even harder. So I think we'll stop there. I'm not really going to stress 3-dimensional arrays in this class. I think 1 and 2-dimensional arrays are enough for your first class. You should know that 3-dimensional arrays exist, and that's really, there's not much in your book mentioned about it either. It's just the fact that you know that there can be more dimensions, and you understand the idea that you can have just one student scores, or you can have multiple student scores, or you can have multiple student scores across multiple classes or semesters. You know, you can keep going with the dimensions, and then I can add another dimension of years, go across multiple years. I can keep adding more dimensions, right? But it gets more complicated. Okay, agree with me? So vectors we'll say for next week. We'll stop here. Does anybody have any questions? I know that was kind of a lot to take in. Are y'all still with me on Zoom?
Yeah.
Okay, I'm gonna
Yeah.
stop